Hey guys, this is section 2.5. We're going to be looking at solving quadratic equations. So what is a quadratic equation? We're specifically looking at one variable here, but it's an equation that can be written in the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a does not equal 0. So the reason a can't equal 0 is because if a equaled 0 there, that whole term would equal 0, and you would actually be left with a linear equation. So quadratic equations have to have that highest exponent being 2, so the degree has to be 2. All right, we're going to look at several different ways to solve. The first way we're going to look at today is by graphing. So the graph of the function y equals x squared plus 2x minus 8 is shown right here to the right. How could we solve the corresponding quadratic equation x squared plus 2x minus 8 equals 0 using the graph? So notice that if you compare the function with this equation here, all they did was replace the y with 0. So what you're looking for on the graph is where y equals 0, which of course is this entire x-axis. So where does that quadratic equal 0? Well, it's going to be where it crosses the x-axis, right here. That's where y equals 0, and here's the other place where y equals 0. So your two solutions would be x equals negative 1, 2, 3, 4, negative 4, and positive 2. Okay, so just to kind of summarize that, if you're looking at a graph, then the solutions are going to be where the parabola, it's called a parabola, that shape right there, that a quadratic makes when you graph it. It's going to be the places where it crosses the x-axis. We can call these zeros on the graph. Okay, so zeros, and that's just where y equals 0. Okay, another little question right here for you to think about. If m times n equals 0, then what must be true about m and n? So think about that. Try to come up with the solution on your own. Okay, so if m times n equals 0, then m or n, or both, must equal 0. So you could say either m equals 0, n equals 0, or both. Or both equal 0. Okay, so we can use that statement or that fact to actually solve quadratic equations. So it's called the zero product property or zero factor property. If m and n are complex numbers with m times n equaling 0, then either m equals 0, n equals 0, or both. Just like we just said, equals 0. Okay, here's how we can use that. So you can actually just set the quadratic equal to 0, so move everything to one side. And then you can factor it. And then because of what we just said, the zero product property, then one of your factors must equal 0 in order for the equation to be true. So you'll set each factor equal to 0 and solve. And that way you can get your two solutions. So I should maybe point out that with quadratic equations, you will always have two solutions. So whereas with linear, you have one solution, with quadratic, you're going to have two. So you'll notice that the degree on the equation, or the degree on the polynomial, does tell you how many solutions you're going to have. All right, so let's try it here. Write the quadratic in standard form. Done. It's already in standard form right here on number 1. Step 2, factor. So looking for two numbers that add to 1 and multiply to negative 20. So 1, 20, 2, and 10, 4, and 5. So it's going to be 4 and 5. They need to multiply to negative 20 and add to positive 1. So I'm going to make the 4 negative. So that will be x minus 4, x plus 5. Okay, and now step 3, set each factor equal to 0 and solve. So x minus 4 equals 0, x plus 5 equals 0. So remember, the reason we're doing that is because in order for these two to multiply and get 0, one of those two has to equal 0 or both, right? And so we want to see what numbers would make each of those factors equal 0, and those are your two solutions. So adding the 4 to the other side, I get x equals 4. Subtracting the 5, x equals negative 5. So those are my two solutions. X equals 4 and x equals negative 5. Could write that as a set. That would be x equals negative 5 and 4. All right, number 2. First, we need to write this in standard form, so I'm going to subtract the 12. We need it to be equal to 0 in order to use that property that we're talking about, the zero product property. If it doesn't equal 0, then we can't use that. So we're going to subtract the 12 over first. So subtracting 12 gives me minus 50 right here. Okay, and then I'm going to factor the 2 out. And I'm left with x squared minus 25. So just taking out that GCF of 2 that I saw. Okay, now I've got two terms, and they are both perfect squares. We've got the difference of squares here, so we can factor that. Square root of x squared is x. Square root of 25 is 5, so x minus 5, x plus 5. Okay, now we'll set each factor equal to 0 and solve. Because this is just a 2 on the outside and not like 2x, we don't need to set that equal to 0, right? 2 equals 0. That's never going to happen, so there's no solutions there. But if there were an x, you would set that equal to 0 and solve. But if there's no x involved in the GCF, then you do not need to worry about it. Okay, so we've got x minus 5 equals 0. That gives us x equals 5. And I've got x plus 5 equals 0, which gives me x equals negative 5. So x equals, you could actually just say plus or minus 5. Okay, and number 3. So it's already in standard form on this one. So let's move on to factoring this. There is no GCF here. 4, 15, and 9 don't have a common factor. So what we need to do is the AC method. 4 times 9 is 36. So we need two numbers that add to 15 and multiply to 36. Okay, I already see what I need right there, 3 and 12. They need to multiply to positive 36, so they need the same sign. And then they're adding to positive 15, so they both need to be positive. So I'm going to factor this by grouping. So 3x, 12x, just breaking that up. Okay, and now we can factor. GCF for each group, just x on the first group. And then I have 3 on the second group. Okay, so now we see we have our matching parts, 4x plus 3, take that out. That is your GCF for those two terms, and you're left with x plus 3. All right, now we set each one equal to 0 and solve. So that's minus 3. And then divide by 4. So x equals, probably shouldn't write that down here. Whoa. So divide by 4, so x equals negative 3 over 4. And then x plus 3 equals 0. Subtract the 3. X equals negative 3. So our solution for this one, x equals negative 3 over 4 and negative 3. All right, so we've looked at solving quadratic equations, looking at a graph, just looking at those x-intercepts, the zeros on the graph. And then we looked at solving using factoring. So you would factor, set each factor equal to 0, and then solve for x. Another way to solve is using square roots. So this actually is only going to work in some cases, and that's going to be where you don't have that bx term. So if you have ax squared plus c equals 0. So if you can write the equation in that form, then that's when this is going to work primarily. Okay, so for example, if I have x squared equals 25, what could x be? What number squared gives me 25? We're obviously thinking x equals 5. But also, x equals negative 5, right? Negative 5 times negative 5 is positive 25. So you're going to have two solutions. Like I said, quadratic equations always have two solutions. So what that means is when you solve this, you can solve by taking the square root, but you need to make sure to add plus or minus because it can be positive 5 or negative 5. So here's the square root property. If x squared equals k, then x equals the square root of k, or x equals negative square root of k. Okay, so it'd be plus or minus. Thus the solution set of x squared equals k is square root of k and negative square root of k, or you can write that as plus or minus the square root of k. All right, so let's see how this works. We've got x squared equals 29, so we're going to take the square root to solve, but you need to have that plus or minus. So x equals plus or minus the square root of 29. If you could simplify that, you would need to, but you can't simplify the square root of 29, so that's just your answer. All right, number 2, we'll take the square root to solve, plus or minus, x equals. So let's simplify this, the square root of negative 144. So anytime you take the square root of a negative, remember we get that I, so plus or minus I. And then the square root of 144 is 12, right? We don't want to write it like that, so we're going to write plus or minus 12i, always writing that number in front of the imaginary I. All right, we can do that again here on number 3. because I can just take the square root to get rid of that exponent. Square root of, so plus or minus the square root of 24, but actually 24 can be simplified. That's 4 times 6, and we know 4 is a perfect square, so take the 4 out, it becomes a 2. The 6 is stuck inside. Okay, in solving for x, we need to just add that 8 to the other side. So 8 plus or minus 2 square root of 6 is your answer. Can't combine those because they're not like terms, right? This one has a square root of 6 attached to it, while the 8 does not, so you're going to leave those separate. So your two solutions on this one are 8 plus 2 square root of 6 and 8 minus 2 square root of 6. Okay, so just so we're clear, we do still have two solutions there. They're just written together. All right, number 4. Before we can take the square root, we need to subtract the 9, right? Because otherwise I'd be taking the square root of this whole thing, which honestly don't really know what would happen there. Okay, so subtract the 9 first. And now we can take the square root. The square root of 81 is 9, so we're going to have plus or minus 9. Subtracting the 17. So negative 17 plus 9. That gives us negative 8. So just to be clear on this, we are doing plus 9, negative 17 plus 9, and x equals negative 17 minus 9. If this actually simplifies to an integer, you're going to want to go ahead and add and subtract those two numbers. Okay, so your two solutions are negative 8 and negative 26. All right, number 5. If you want to try this one on your own, go for it if you're feeling comfortable. So add that 9. And then square root. So p equals plus or minus the square root of 59, which you can't simplify, so we're just going to leave it like that. All right, now we have a literal equation, but it involves a quadratic here. So let's solve it. Okay, if I'm solving this for r, first thing I like to do is just get rid of this fraction in the front. So I want to multiply by 3 to get rid of 1/3. It's like you're multiplying by the reciprocal of 1/3, which is 3 over 1, or just 3. Because 3 divided by 3 is 1, so that cancels. So we've got 3b equals pi r squared h. And if I'm solving for r, I need to get rid of the pi and the h. So I'm going to divide by pi h, because right now they're multiplying. The opposite of multiplying is dividing. So to get rid of pi and h, I'm going to divide by pi and h. So that leaves me with r squared equals 3v over pi h. And finally, to get rid of that exponent, we're going to take the square root. So r equals plus or minus the square root of 3v over pi h. All right, and that concludes our notes for today. We'll continue this in part 2 tomorrow.